Hey guys, AC here, back with another video. Sorry for not uploading. It's been a minute. I've been really busy on the weekends, so I haven't been able to make videos really. I'm gonna try to keep this one short. Try to do it in one take. I'm doing it on my laptop, so the audio quality will be kind of bad. This is gonna be a different kind of video. I'm not gonna be going over specific problems. This is gonna be more focused on reviewing the chapter, which is chapter 10. Let me know if you guys like this format. And anyway, let's get started. So, chapter 10 review. So, this chapter is mostly on things like it's mostly revolved around things like circles and angles within these circles and sometimes outside of the circles as well. So, let's get started. 10.1, pretty simple section, right? Main things to remember is that the radii are congruent. Radii of the same circle are congruent. So, a simple problem like this. The radius is 12, we have to find the distance from the chord to the center. So if we know the radius is 12 here, then we can solve for this using the Pythagorean theorem. Right, pretty simple section. 10.2, congruent chords. So main things to remember is if the chord is congruent, then the connectors are congruent and vice versa. That's shown right here. So if right here the chords are congruent, then that means that their segments, or if the connectors are congruent, then the chords are congruent as well. And this is a sample problem I just came up with right here as well. So 10.2, also pretty simple. 10.3, arcs of a circle. So the main things to remember about this section, make sure you know all these words: diameter, radius, chord, arc, minor arc, major arc, central angle, and a semicircle. So diameter, radius, chord, arc, these should be pretty easy. If you read this far, you should already know what these words mean. Minor arc, arc less than 180 degrees. Major arc greater than 180 degrees. Central angle is an angle from the center of a circle. And a semicircle is just half a circle. And then these are some problems as well, right here and right here. That should help you better your understanding of the section. Tangents and secants. Okay, so this is where we start to get into the complicated stuff of chapter 10. So, main things to remember. Externally tangent lines, internally tangent lines, the secant line, tangent lines, and radii at a point of intersection create a right angle. So these are a few things that are super important. So first off, externally tangent lines. That's going to be this line right here on the bottom left of the screen. Internally tangent lines is going to be lines that look like these, which will cross the lines connecting the centers of the two circles. It's going to look like this. A secant line, right up here, it's going to be this blue one. It's going to come through the circle, and it's going to end right at the furthest point for the circle. Not the furthest point of the circle, but not this part of the circle. Opposite to that, a tangent line, it's going to end right where it meets the circle, and tangent lines only intersect the circle once. And then tangent lines and radii at a point of intersection create a right angle. So for example, if I bring this down here to point A, I know that this will form a right angle. And that's very similar to how you solve this problem. This is a sample problem here. So we have to find the common external tangent AB, which is this line right here. And the simplest way to do it is first to create right angles from this on these two sides. And notice what I wrote here always create a line parallel to the external tangent. This is a super important point. So the external tangent, AB. So let's create a line parallel to AB from the small circle, always from the small circle. And let's create a parallel line here. So if the lines are parallel, we know these are right angles. And from here, if we know the length of right here, we're usually given the radius. So we know what this is, and we know what this is. Since we already know what this is, because it's a rectangle, that length is going to be the same as this length right here, which means we also know this length. So now if we know this length, and we're also given this length, usually, then we would be able to solve for this length, which is equal to like a common external tangent. And then in this section, we're also introduced to something called walk around problems, like this. They usually look like this. And you usually have to solve for like this side, or solve for x, which would be labeled like right here, like this, or something like this. And biggest hint I'll give you here is that tangents are congruent. That's usually how you would solve this problem. Anyway, that's 10.4. Let's move on. Oh, let's not move on. And then usually there's going to be one more type of problem in 10.4, and that's going to be something like this, where you're going to have to find the internal tangent, in this case AB. And in this case, I will tell you, use ratios, so make sure to always connect a radius to these tangent points like this, which create right angles. And these triangles may or may not be similar. And what I want you to do for problems like these is to use ratios. Use triangle ratios, and they'll help you a lot. So now, let's move on to 10.4. So angles related to circles. This is where things start to get a little bit harder and a little bit more confusing. So main things to know is we want to know how to solve all 6 of these angles. So you have inscribed angles, tangent chord angles, chord angles, secant angles, tangent angles, and secant tangent angles. So let's start with the top. Inscribed angles. So usually inscribed angles, they look like this right here on this picture. And the easiest way to find these is to just take half of the intercept arc. So in this case, to find the measure of angle C, we just take half of the measure of the arc AB, which it intersects. Quite simple, right? Tangent chord angles. Same thing, so we see a chord here and tangent BD. So what we're trying to find is angle C here, right? So the measure of angle C right here is equal to half of the measure of arc AB, which is right here. And that will give us the measure of this angle, which is the same. And then chord angles, this is the one you have to memorize that is always different from the rest of the other 5. So instead of subtracting here like these and later on these angles, we're actually going to add them together. We're going to find the average. So this is usually what chord angles will look like, and we're trying to solve for like COD or AOB, these angles right here. So what we're going to do is we're going to add arc 1, in this case CD, and add arc 2, in this case AB, and then divide them by 2, and that will give us the angle of this. And because of the vertical angle theorem, both of these are congruent. So in this case, measurement of AB plus the measurement of arc CD over 2, yeah. And then secant angles, tangent angles, and secant tangent angles. So these will be probably the hardest to find. So in this case, in a secant, right, we're going to take the arc AB minus the arc of CD, and we're going to divide it by 2. Or right here, if you can see, we're going to find the larger intersected arc minus the smaller intersected arc and divide the entire thing by 2. And that will give us the measure of this external angle, sort of, right here. So, in this case, AB minus arc CD over 2 will give us the measure of this angle. Then in this case right here, this tangent, we're going to subtract this larger arc. So let me label a point right here. So we're going to take arc ACB minus arc AB divided by 2, and that'll give us this angle. And then in our final one, a secant tangent angle, all we're going to do is we're going to take the same thing. We're going to take this larger arc right here, subtract it by this smaller arc right here, divided by 2, and we're going to get this angle right here. So yeah, that's 10.5. And I think, yeah, here are some problems to help you better understand. Okay, 10.6, more angle arc theorems. Main things you really just have to know for this section: an ascribed angle of a diameter is always 90 degrees. So in this drawing right here, as you can see, there's a diameter here, and an inscribed angle, it will always be 90 degrees, no matter what. And then for this section, you just have to fully understand all the types of angles, like all of these types of angles. And then here are 2 problems that can better help you understand angles. Okay, 10.7, inscribed and circumscribed polygons. Main things to know for this section: opposite angles of inscribed polygons are always supplementary. Actually, this should be inscribed polygons. Okay. Opposite angles of inscribed quadrilaterals are always supplementary. And then you just need to fully understand how to do walk-around problems. So here's a walk-around problem. And then here's a sample problem that I made. So you need to find angle ABC. So the measure of this angle right here. ABD, the measure of this angle, sort of created like right here. And then ABE, so this angle right here. And then one more problem. So X is the intersection of AE and CG. And this point right here is X. And what we need to do is find GXE. So I think the best approach to this problem that I'm going to give you is to inscribe the shape inside a circle. And remember to find the interior angle of a shape. A regular polygon is 180 minus 360. Well, that's a 360 over n. And n in this case is the number of sides that the regular polygon has. Okay, tangent secant power theorem. So you're usually going to have obviously a tangent and a secant. So the tangent squared will be equal to this segment right here, RT, and this entire segment, RS. Make sure you're not doing RT times TS. That will yield you a wrong answer. And the secant power theorem will be in red right here. So we have 2 secants right here. And in order to calculate these, we do, once again, CA, the entire segment, times CB, the external part, is equal to CE, the entire segment, times CD, the external segment. It's just like the tangent secant. And then here are some problems as well to help you solve these. Okay, 10.9, last one, circumference and arc length. So, main things to know about this section: you need to have a full understanding of circumference. You need to fully know how to find areas and perimeters of sectors, and finding areas and perimeters of combined shapes. So, I just have some problems here. There's not much else to talk about in this section. No tricks, nothing. And yeah. So, if you like this format of video, let me know. I'd love to hear you guys' feedback. I'm not sure what works well for most of you guys, so yeah, just let me know. And I'll see you in the next video.